Okay, so we are live and we are waiting for our attendees. Dzień dobry Państwu. Czekamy, aż wszyscy się pojawią, bo po kolei wpuszczane są kolejne osoby. Witamy Państwa na kolejnym spotkaniu w fantastycznym klubie WeInnovators Club. Mamy kolejnego znakomitego gościa, którego w zasadzie Paweł upolował na LinkedInie po tym, jak kiedyś ja powiedziałem, że jest to jeden z moich ulubionych futurologów. Witamy doktora Aubrey'a de Grey. Myślimy, że naprawdę to jest jedna ze znaczących postaci na rynku innowacji i przyszłości, tak? W tym to jest człowiek, który ewidentnie na tym się zna. O, dołączyła do nas pani profesor Urszula Wojda. Zaraz będzie mogła coś powiedzieć. Ja tylko szybko powiem, bo nie chcę przedłużać. Cieszymy się, że po raz kolejny jesteśmy z Państwem. Cieszymy się, że kolejnym znakomitym gościem będziemy mieli spotkanie. Cieszymy się, że pani profesor zgodziła się moderować tę sesję. Pawle, dodaj coś od siebie i przekażmy głos już tym, na których wszyscy czekają.
Ja tylko chciałem bardzo podziękować jeszcze raz pani profesor, że zgodziła się być moderatorem. Pani profesor reprezentuje Instytut Biologii Doświadczalnej Polskiej Akademii Nauk. Bardzo dziękujemy, że jest pani z nami dzisiaj. Poprosimy o... Musimy tylko poinformować panią profesor, że jej nie słychać.
A teraz spróbujmy jeszcze raz.
Teraz jest świetnie.
Rozumiem, dobry wieczór jeszcze raz Państwu. Bardzo się cieszę, że udało mi się połączyć. Rozumiem, że przechodzimy na język angielski już w tej części, prawda?
Yes, let's do it in English. And,
so okay, good evening again. Right?
Thank you very much. So, Professor, the floor is yours.
All right. Well, first of all, I would like to thank the organizers very much for inviting me to give this talk. It's been a very long time since I was in Poland, and I always love to speak to a new audience. So first of all, just let me share my screen and get my slides going.
Doctor, could we give a chance to say a few words to Professor Urszula Wojda?
Oh, sure. Go ahead, Ursula, please.
Okay, so I understand that the best, as an introduction to this presentation, to this lecture, would be to say a few words about our guest. So it's really my great pleasure to introduce to you Dr. Aubrey de Grey, who is a bioinformatician and a biogerontologist. Also a founder of the foundation SENS, Strategies for Engineered Negli-gible Senescence, which is focused on damaged by aging, all molecules in the cell body, and on complex methodology for restoration of these damages. Moreover, he runs a laboratory. He works in Mountain View in California, USA, and he performs a lot of different, he's involved in different activities, of course. He is, between others, editor-in-chief of one of most influential journals in this field. The Rejuvenation Research focus on interventions in aging again. On his professional career path, it's worth to mention that he graduated as bioinformatician, but then he obtained his PhD in biology from the University of Cambridge. And since many years, he conducts the research that is just focused on different types of cellular damages, during ages, during senescence, cellular senescence, and the methodology how to restore, how to repair these damages to be able to achieve indefinite use with damage repair, as is stated in the title of this presentation. So I hope this will be at least some information about different activities and achievements of our guest. And without any further delay, I will pass the voice to our guest. Dr. Grey, please, the floor is yours.
Well, thank you very much, Ursula, and thank you again to all of the organizers for setting this up. It's a great pleasure to be here. So first of all, let me just share my screen. Won't be a second. That's good. Okay. Is that okay? Can you see my slides now?
I see perfectly.
Good, great.
Cool.
All right, so what I will try to do over the next half hour is I will try to explain my reasons for believing that we are now quite close to bringing aging under comprehensive medical control. Of course, we can never be certain that that is true until we achieve it completely, but I will explain why we have been making great progress in that direction, and it's looking good right now. I will start by giving a lot of background because still many people, even many biologists, are, in my mind, very confused about what aging is and how we might in principle even solve it as a medical problem. So I will talk about that. And I will talk, of course, also about the progress that has been made by SENS Research Foundation and indeed by other groups in recent years, and where this is going and what it means. So, wait a second, my computer is not letting me advance my slides. Won't be a minute. Okay, this is strange. I apologize for the problem. I will get it working somehow.
Okay,
Okay,
let's try one again.
No, I have, I think I have fixed it. Give me a second. Okay, and there we go. There we go. All right. So, so first of all, the nature of the problem. So as we all know, life expectancy, the average time that people live, has been going up for quite a long time, for at least 150 years. Before then, really nothing was happening. We didn't have modern medicine as we know it today at all. And even in the wealthiest countries in the world, most people would die quite young. In fact, the average lifespan was only around 30. But then, of course, things started to improve. And at the moment, we have had for some time now this trend of increase. So here I am showing, just for illustration, statistics from the United States. And of course, there are many ways to present this phenomenon. Here I am showing the proportion of the US population that is over the age of 65 and how that has changed between 1950 through to a projection out to 2050. And that, of course, is a great thing. We don't like to see people dying young, but it has a downside. And of course, the downside is that if people don't die young, then they live long enough to get the health problems of late life. And those health problems are rather different from the things that used to kill people early in life, in the sense that they kill people slowly. If you get an infection that kills you, it probably kills you almost at once. But if you have cancer or Alzheimer's disease or atherosclerosis and so on, then it's a slow decline before you die. And that, of course, is the reason for what I'm showing you on this graph. Again, I'm showing you US statistics, but it's the same across the entire industrialized world. The red line is the growth of the US economy in just 50 years, starting from 1960 through to 2010. And the blue line is the growth of US expenditure on medical care during that same period. If we draw it like that, it doesn't look particularly frightening, but it looks terrifying if we divide the red line by the blue line. That's what the green line is, the proportion of the US economy that is spent on medical care. In just 50 years, it went up from 5% to 18%. So more than threefold. And that's, of course, why everybody thinks that, medical welfare is going to go bankrupt. And this is true across the whole world. So, well, what do we do about it? Well, I always believe that the first step in solving a really difficult problem is to ask the right questions. And that doesn't necessarily happen in this case. So this, I believe, is the question that we must ask at the beginning, and people don't ask it enough. The question is, what is different about the health problems of late life, age-related diseases? We have done so well against infections, of course, not against all infections, we know that very well, but most infections have been almost eliminated in the industrialized world. 200 years ago, more than 1/3 of babies would die before the age of 1. And that was even in the wealthiest countries. And now, of course, virtually no babies die before the age of 1. And we did this just by figuring out that hygiene is a good idea and developing really simple medicines like antibiotics and vaccines, and even mosquito nets. These things have saved huge, huge numbers of lives. So what is different about the age-related diseases? Well, some people think the main difference is that there are so many of them and they all happen at more or less the same time. So of course, you're not supposed to be able to read this slide. I'm just trying to point out how complicated the thing is. And most people think, well, this is just the whole reason, that the medical profession has been overwhelmed by the complexity of the phenomenon of what goes wrong with people late in life. And for sure, that is part of the problem, part of the reason why we have had such little success. But the first thing I want to explain to you is that actually it's not the main reason. And the main reason is much more interesting. In order to introduce that main reason, I'm going to start by giving you a definition of aging. Now, again, this is crazy that I would need to do this. Aging has been the #1 preoccupation of the human race since the beginning of civilization. So it's very strange that people do not even have a shared common definition of aging, but we don't. So I'm going to give you this one. And there are 2 reasons. First of all, it's so that all of us can be on the same page during this talk so that you understand the rest of what I'm going to say. But the other one is just as important. This is a way to demystify aging, to explain to you that aging is not some strange enigma that we totally don't understand. We actually do understand aging pretty well now. So what am I saying here? Aging is simply the combination of 2 processes. A process on the left that goes on throughout life, even starting before we're born, and a process on the right that starts late in life. The process on the left is the creation of damage in the body. Now, what is damage? It's simply changes to the molecular and cellular structure of the body that happen as consequences of our normal metabolism, of the network of processes that keeps us alive from one day to the next. And those changes are progressive, they accumulate. Now, the reason why it is appropriate to use the word damage to describe those changes is because of the right-hand process. The body is only set up to tolerate a certain amount of that change. While the amount of change is below that threshold, nothing else happens. Damage is harmless. But eventually there's too much damage, and that's when the right-hand process starts to happen. We start to become less functional, both physically and mentally, and those problems progress. Those are the pathologies of late life. So that's all that aging is. It's the combination of those two processes. Now, you may be wondering, why am I taking such a long time and trouble to describe this with such care? This is why. If you get it wrong, then you make a whole bunch of other mistakes too, and those mistakes really matter. The first mistake that people make is they have a bad idea of what is aging and what is not aging. So if you ask people, most people, and this includes most biologists, in what way can somebody get sick, then they will give an answer that is something like what you're seeing on this table. They will say, well, okay, there's infectious diseases, that's column 1. Then there are genetic diseases, things that a small number of people inherit from their parents, that's column 2. Then there's the big one, the chronic progressive diseases of late life, like Alzheimer's and almost all cancers and osteoporosis and so on and so forth, all those things that I put up in really small print earlier on. And then most people would say that there is this fourth category of fourth way to be sick that's completely different from diseases. It's called aging itself, and it consists of these rather poorly defined phenomena like frailty. And it's so different from diseases that the implication is that it's kind of off limits to medicine. That's really the way that people think about being sick, about what aging is and what aging is not. And it's completely wrong. This is the right way to think about the ways in which people can be sick. If you look closely, you will see that all 4 of the columns are exactly the same as before, but the difference is where that big thick black line is. So that tells us 2 things. First of all, it tells us that column 3 is nothing like column 1, and that's really important to know, because it means that we do not have any particular reason to believe that the things in column 3 could be cured by the same kind of medicine that we use so successfully for the things in column 1. And the other thing it tells you, by putting the black line in the right place, is that there is basically no difference between the things in column 3 and the things in column 4. In fact, there's no biological difference at all. The only difference is semantic. The things in column 3 are the aspects of aging that we have chosen to give disease-like names to. That's all. Now, if you make that mistake, this is the problem. As I mentioned, there is no reason to believe that the same kinds of medicines that work against infections should also work against Alzheimer's disease, for example. But that's what we try to do these days. All of geriatric medicine consists of waiting until somebody gets sick, until the pathologies of late life have become really bad, and then trying to cure them, like we would try to cure malaria. It's crazy. You can see just by looking for a moment at this simple diagram that it would never work. It's not just the complexity that I mentioned earlier, it's the fact that the pathologies of late life are being driven by something that's continuing to accumulate, this damage I'm talking about, which means that by definition, any medicine that directly attacks the pathologies of late life is certain to become progressively less effective as people get older. So it's just a non-starter. So you may ask, well, why are people so dumb? Why have people spent so long and so much money clinging to this crazy approach that will never work? Excuse me. Well, of course, one possible answer is there's no alternative. This is all we have. But that's not true. More than 100 years ago, people started to realize that actually there was an alternative. They started to realize, just a few people, of course, that geriatric medicine will never work. And they thought, well, okay, let's try to be more preventative. In particular, let us try to make our metabolism run more cleanly. try to have it create damage more slowly than it naturally does. If we could do that, great. We will postpone, we will delay the age at which the damage reaches a point that starts the right-hand process that causes pathology. That's wonderful. And of course, the inspiration for this was the living world. The fact that if we look at different species, we see a huge amount of difference in the rate at which they accumulate damage, a huge variation. Even within a species, we see a certain amount of variation. So the idea was, if we study that variation really, really hard, then maybe eventually we will understand our metabolism, we will understand the left-hand process well enough that we can invent therapies that will slow down the left-hand process. And that would be wonderful. But unfortunately, in that 100 years, nothing has happened. We have not developed any therapies that work this way. And this is why. Metabolism is very, 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 very complicated. What I'm showing you here, of course, is part of a biochemical chart. This is a simplified diagram of a small subset of what we know about how the body works, how metabolism works. And you can immediately see that there is no way that we could possibly stop it from doing the things that we don't want it to do without having unintended consequences that stop it from doing things that we need it to do to keep us alive. It's just not going to happen. If any of you have ever written software, you will see that this is the ultimate nightmare of uncommented spaghetti code, right? So there's no way. But luckily, there is a third alternative. And this is the damage repair approach that I focus on. The idea here is, okay, the goal is to separate metabolism from pathology, to break the link between metabolism and pathology so that we can carry on performing metabolism, in other words, being alive, for a longer time without the pathologies that we currently see late in life. And we have seen that it's not going to be possible to do that by breaking the right-hand process, by stopping pathologies from happening, even if damage is happening. We can also see that it's not going to be possible to break the left-hand process. Metabolism just is going to create damage, whatever we do. But the alternative is to separate those two processes from each other. If we go in and we periodically repair the damage, even if we don't do it particularly thoroughly, we will still get to a point where we can let metabolism create damage at the normal rate. We don't have to slow it down. And yet, the damage will not reach the level that causes the pathologies of late life. So that is the goal here. And really, you know, it may be much more feasible. We can do it without even understanding much about the left-hand process and the right-hand process. If we don't need to slow down the rate at which metabolism is generating damage, then we really don't need to understand all that much about how it generates damage. And the reason why I call it the common sense approach is because we already do it. We already do that exact thing for simple man-made machines like cars. This car is more than 100 years old and it's working just as well as when it was built. Why? Not because it was designed to last 100 years, not at all. It was designed to last probably 10 years. But it has benefited from thorough, comprehensive, preventative maintenance through all those 100 years. And what we're seeing in front of us is that that works. Preventative maintenance works. Now, you may say, well, that's just a car, right? I mean, it's not a living organism. But wait, what's the difference? The human body is a machine. It's a really, really, really complicated machine, but it's still a machine. So its function is determined by its structure. And therefore, damage repair should work just as well on the human body once we figure out how to do it, as it does already on simple man-made machines. A way of saying that in one line is that aging is not specific to biology. It's not like, you know, consciousness, some kind of emergent thing that can only be possessed by living organisms. it's really a phenomenon of physics. Comprehensive preventative maintenance just works. So now, let us come to the one question I have not yet answered. Can we actually do this? Is it feasible? I've emphasized already that metabolism is incredibly complicated, and also that the pathologies of late life are incredibly complicated. So maybe the thing in the middle, the damage, is also incredibly complicated. And if so, then even if this is the common sense approach, it may still not be feasible. It may not be practical. So the good news is that's not the case. 20 years ago, I began to think about this, and I realized that actually we can describe the damage that accumulates in the body really easily. We can subdivide it into a very manageable number of categories. And those are the things on the left-hand side of this table. And the reason why that's such a useful thing to do is because within each of the categories, there may be many examples of damage, but there may be a generic way to actually do the damage repair. And sure enough, there is. If we look on the right-hand side of this table, we can see the way to do this. Now, if you look closely at these things on the left, you will see they are very large, wide categories. So for example, cell loss, what's that? It's simply cells dying and not being replaced by the division of other cells. And yeah, I mean, that happens in lots of different parts of the body during aging. And, you know, we have different types of cells that are dying, and we need to do different things to fix them, but not very different. Essentially, every type of cell loss can be repaired by stem cell therapy. Different stem cells for different organs or different tissues, but still stem cell therapy, and all stem cell therapies have a lot in common. So right now, we are in this stage where one of the most important parts of aging that's driven by cell loss, namely Parkinson's disease, which is caused by the loss of a particular type of neuron called a dopaminergic neuron, that's now being in clinical trials, being treated with stem cell therapy. I don't have time to go through all the other categories, so let me just say, the reason that we created SENS Research Foundation was because the other categories are not so far along, or at least they were not so far along 20 years ago. All of these things need to be repaired. Any one of these types of damage can kill you on its own, however well we fix all the others. So we need to develop these other maintenance approaches, these other damage repair approaches as well. And that's what SENS Research Foundation has been doing all this time. We've done quite well. We have been focusing on the most difficult components of this process, and we have published quite a lot of papers on it. I have picked out these 4 papers just because they are the most important ones that we've published, the ones which were really huge breakthroughs that kick-started whole new areas of research that people had given up on for 10 or 20 years beforehand. And we showed that people had given up too easily. So we're very proud of this work that we've done. And now this whole idea of a divide and conquer damage repair approach to the problem of aging is mainstream. Everybody is doing it. So this paper came out in 2013. That's more than 10 years after my original description of this idea. And as you can see, it's pretty much exactly the same. They split aging into 9 categories instead of 7, but that's not because they identified anything new that I had overlooked. It's just a different way of doing the classification. And sure enough, they've got their corresponding repair therapies. And this paper has become holy scripture in gerontology. Everybody cites it. It's now actually over 2,500 citations. It's easily the most highly cited paper in the whole of the biology of aging for the past decade. So this idea, I don't have to justify this idea anymore. 15 years ago, a lot of people thought it was crazy, but nobody thinks it's crazy anymore. So now I want to just briefly talk about the societal context of this. I do a lot of media, a lot of interviews and so on. And the media, of course, they make their money by being sensationalist. So quite often You know, they will describe me as the prophet of immortality or something like that. But we don't work on aging. We're on longevity, let alone immortality. We work on health. We just do medical research, right? Longevity is a side effect of health. Of course, it's a big side effect because most people die from being sick. And if we can do what we want to do, which is to stop people from getting sick at all when they get old, then the magnitude of that side effect will be big. But it's still just a side effect. So when people say things like this, you know, they say, oh dear, you know, where will we put all the people, or won't it only be available to the rich, or won't dictators live forever, or how will we pay the pensions and so on? You know, really, these are concerns that arise from forgetting that this is a health issue and just focusing on this longevity consequence. And besides, you know, let's have a sense of proportion. Even if we could not avoid these things on the left, which of course we can, it's very easy to see how to avoid them. You know, is it really that these problems will be even worse than the problem we have today, where the huge majority of suffering in the world is caused by aging, by the health problems of late life? It's just crazy. So I want to end by talking a bit about how things are changing in the past couple of years. The big thing that has changed just in the past 5 years is that investors from the private sector have started to get very interested in this field. The result is that we have actually been able to spin out half a dozen of our projects into startup companies that have been able to receive a lot more funding from investors than we could ever give them from our nonprofit in California. So that's fantastic. And it's just the tip of the iceberg. There are way over 100 companies now, probably 200 or 300 companies now working in this space. If you look at the bottom right, you can see a website that one of the big investors in this space has created. So that's the place to look. I can't keep up with it anymore. There's far, far too many. I just can't keep up. So this is fantastic that there is such a lot of activity, because it means it will happen faster. So let us now come to the last part of what I want to say. How long will it take before this happens, and how big will the longevity side effect be? Well, of course, I don't know the answer to the first of those questions, because this is pioneering technology and it's all speculative. But I think that I have a responsibility as an expert in this field to say something about this, to give my best guess as to how long it's going to take, because otherwise people will make up their own best guess and it won't be so good. It will be too pessimistic. I think that within the next 16 or 17 years, we have at least a 50% chance of reaching a point that I have called longevity escape velocity, which I will define in a second. It could take longer. There's at least a 10% chance that it will take 100 years, but I think it will only take about 15 or 20 years. Now, those therapies will give us a lot of extra life, maybe around 30 years, because they will repair most of the damage that the body does to itself throughout life. They won't give us indefinite youth, but they will give us maybe additionally 30 years. The thing is, though, that is 30 years of time that the scientists in this community will have to improve the therapies, to give another 30 years and another 30 by making the therapies more and more comprehensive. That's what I call longevity escape velocity. And I just finally want to draw your attention to the last line of this slide. Even way before that actually happens, way before these therapies really exist, the world is going to understand that they are coming. People at the moment still mostly believe that they will live only slightly longer than their parents did. But very suddenly, in the next few years, I believe, people will start to realize that these therapies are coming and that they will probably never need to get sick, however long they live. That's the world that I'm trying to bring about. If you want to know more about the scientific basis of all of this, please read my book, Ending Aging. I should mention that actually just yesterday, somebody wrote to me saying that they would like to translate my book into Polish. So maybe that will happen quite soon. But for the moment, here is the English version. There are various other languages, including German. I guess a lot of Poles speak German. So please have a look at this if you want to know more about the science. And I will be happy to stop there and to answer some questions.
Thank you very much for this inspiring talk. And now the presentation is open, obviously, for questions, from all of you who are interested. And maybe I could start when you think about the problem you can touch. And I would like to refer to the central part of this hypothesis, where you showed us the consequences of the metabolism as a damage leading to pathology. And this is in contrary to the concept that actually we deal with healthy aging versus pathologic such as Alzheimer or many other neurodegenerative diseases, cancers, and so on. And in fact, we do have examples of centenarians from which we can learn a lot, probably by investigating the mechanism that were involved in their survival. Moreover, not only centenarians, but non-demented centenarians, right? So if they live probably long enough, maybe they will get some pathology, but we can't say it. We know by studies done in centenarians that there are people who follow rather this healthy aging pathway, not always going to pathology. So what is your view on it? Is this a continuum? Is this the due way of aging, or is there a pool of supporting mechanism that can be activated to block the damage?
So it's an important question. So I mentioned earlier that in my view, there are aspects of aging that we give disease-like names to, and there are aspects that we don't, and that there is no real biological difference between the two. But of course, still, you may ask, okay, what is the difference that causes us to put some aspect of aging into one of those two categories and some into the other category? And I think the answer is simply medical definability. In other words, if we can easily say, as a medical professional, if we can easily say whether somebody has a particular aspect of aging or whether they don't, then it becomes a disease. And if there's some just very, very broad continuum, then we can't. But I look at centenarians and I say, well, okay, it's not really the whole picture if we just say, well, they don't have Alzheimer's, they don't have cancer, they don't, we have a list of things that we call diseases and they don't have them.
Obviously.
Because the fact is, they still can't keep up with their granddaughters on the dance floor, right? They are still not as functional as they were 50 years or 70 years ago. They're physically and mentally not so good. So we should be looking at function. We should be looking at how far people are from useful function, rather than starting by defining a particular problem and saying, okay, does the person have that problem or not? So that by that definition, centenarians are not healthy at all. We should not call it healthy aging.
That is obviously a controversy in the field, especially when you listen to clinicians. They really focus on defining the pathology because having the broad definition of what is health and what is a status of a pathology is the basis for any attempt to cure, which in your opinion is, much earlier, a time for intervention is much earlier. So the prevention rather than let's say, trying to reverse the damage when the damage reaches the uncurable level. That's
okay.
all I do.
There are two things I want to say. First of all, I'm not putting the doctors down here. The doctors are doing what they can with the medicine that exists. And of course, you are absolutely right. That means that they have to have some kind of measure of success, even if it is a very small amount of success. You know, a postponement of some level of pathology by 6 months or whatever, it's better than nothing. So I applaud what doctors do, especially since they know that they can't do very much. But that's the difference between MDs and PhDs, right? People who are doing research should not be constrained by what already can be done. They want to create things that cannot yet be done. Okay, that's rather important. You know, okay, I'll stop there.
Yes, I think it's a time for other.
Oh, you're back. You're back. You froze up.
Sorry.
Ursula, start again, please.
I'm sorry. I think we had some interruption from my connection. Anyway, the presentation is open for other questions, comments. You can also write a question, right?
I am seeing quite a lot of stuff in the Q&A and also in the chat. Let me go through the ones that are in English. Okay, here we go. Okay, so first of all, is being rich an essential factor? Absolutely not. The problem right now, of course, is that these therapies do not exist. So it doesn't matter how rich you are, you cannot get them. But when they do exist, the thing is that they will save money, they will pay for themselves. So it will be in the economic interests of governments to make sure that everybody can get them if they are old enough to get them, if they need them, right? Because those people will be able to continue contributing wealth to society. They will not be consuming wealth so much. And besides, prevention is better than cure. One thing you said earlier is that the purpose of this is to intervene earlier, and that's kind of true, but not ridiculously early. We do not have to treat young children because they have not yet accumulated much damage. So only people in middle age and even older, you know, if we treat people who are already sick, we can make geriatric medicine work by fixing the pathologies and also fixing the damage. Then the next question, why do I have a beard like Rasputin? No, it has nothing to do with my scientific career. It's just because my ex-wife liked it. Someone says, what age can you achieve if your approach works? Well, there's no limit. In the same way that there is no limit to how old a vintage car can be. You know, we don't have any 200-year-old cars, but that's only because cars had not been invented 200 years ago. You know, the cars that are 100 years old now will almost certainly still be around working perfectly well 100 years in the future. Then somebody says, does the positive mental attitude still apply? Oh, yes, it does. Well, you mentioned centenarians earlier, Ursula. And one thing that, probably the biggest thing that centenarians have in common is nothing bothers them. They can cope very well with stressful situations. They do not react badly and become stressed. And that is almost certainly very good. Do I believe that climate change has any impact on the length of our lives? No. Is aging a kind of entropy? Yes, it is, but you need to be very careful with that question because it's only a kind of entropy. What happens in the body is that damage is created, but the reason we live as long as we do is because we have very sophisticated systems for repairing most of that damage as it is being created, so that it does not accumulate. The only reason we age at all is because there are gaps in that anti-aging machinery that allow some rare types of damage to accumulate anyway. So you can think of any living organism as a machine that is very good at exporting entropy and therefore not decaying nearly as rapidly as it otherwise would. What is more lethal? I've been smoking, eating alcohol, stress. All of these things that I mentioned: smoking, drinking alcohol too much, stress. All of these things are bad for you. But the single worst thing that's bad for you, that's worse than any of those things, is breathing. And I don't mean breathing polluted air. I mean breathing oxygen, because oxygen metabolism creates toxic molecules in the body called free radicals that are one of the main sources of damage. But of course, breathing is not negotiable. You have to do it. So this is one example of why it's impossible to stop damage from being created. Euthanasia, no, I am quite sure that will not happen. Somebody mentioned climate change earlier. The thing about climate change is that we will stop it with renewable energy and artificial meat and so on. And that will, and all of those ways to reduce the amount of pollution that people make is going to increase the carrying capacity of the planet so that we will have space for a lot more people without any problem. Yes, we certainly need to, somebody asks about preparing society for increased life expectancy. Oh yes, but in particular, we have to prepare people for the economic changes that will occur even before those therapies arrive. I mentioned that earlier. Someone says, what are the strategies to control oxidative damage? Some people have been trying to control oxidative damage with antioxidants for a very long time, and they have had no success. That is because it's part of metabolism. We can't do it. We can't stop that from happening. Therefore, what we have to do instead is repair the damage that oxidative damage that happens before it becomes so abundant that it's bad for us. Someone asks, how big is inflammation in the process of damage? Inflammation is a very important driver of age-related damage, but we must be very careful about this, because inflammation itself, the inflammatory response, is a good thing. It is the way that we eliminate infections. So the correct approach to eliminating age-related inflammation is to remove the things that the inflammation is trying and failing to get rid of. Inflammation is misdirected against things like amyloid or oxidized cholesterol in the body. And those things cannot be eliminated by inflammation, so the inflammation just carries on getting worse. But if we can get rid of the material that is causing the inflammation to happen at all, then the inflammation just won't happen. Somebody says, although we may live longer, we see many health problems at an earlier age. Well, maybe. It's not really true, no. I mean, of course, in some ways it's slightly true. We have an obesity epidemic in the USA especially, but increasingly in other countries. And that is because of lifestyle changes. But you know, we are also getting better at stopping that from happening, at developing drugs that will stop people from getting overweight, even if they go to McDonald's every day. So, no, I think this will go away quite soon. Someone mentions living conditions and character. So again, you know, it has an effect, but a small effect compared to the universal, non-negotiable things like breathing. And he mentions the idea of combining Western medicine and Eastern medicine. I completely agree with that. We definitely need to try to combine these things. Somebody asks whether cancer is connected with age. Well, okay, so yes, I can elaborate. Of course, some cancers do happen early in life, but they are very rare compared to the cancers that never happen early in life. The vast majority of cancers are late life. The reason why any cancers happen early in life is because of extremely unusual rare mutations, which are kind of equivalent on their own, just one mutation, to the occurrence of several independent mutations that happen in most cancers. So the fact that most cancers need several mutations to happen independently, that's why cancer is age-related. It just takes time statistically for that to happen. And these very, very rare mutations can do it all in one go. That's the difference. And then someone asks about fruitarians. Again, lifestyle doesn't matter all that much. Diet doesn't matter all that much. You might, depending on your own metabolism, you might be able to get a little bit of extra life. You should have the diet that works for you. Some people can drink more alcohol than others. Some people can eat more sugar than others. It's a very personal thing. Someone asks, which has a bigger role in aging, the liver or the brain? There is absolutely no answer to that. Everything is linked to everything else. Mm. Okay, I've got to the bottom of the questions. Let me now look at the questions in the chat, which are different. I won't be long. Let's see, the first few are in Polish. I will go down to the first. Oh, right. Someone says, what do I think about the statement that the human body is built for about 120 years? It's absolutely true, but it's also completely irrelevant to the work that I have been talking about today. It's the same as saying that the average car is built for 10 or 15 years. It makes absolutely no difference to what we could do with medicine. That's the same question before. I'm just seeing whether there is any, yeah. All of the other questions are the same as the ones in the Q&A. Okay, I'm done.
Yes, maybe you would like to summarize this part with questions and answers with a take-home message, sure, which could help us to, let's say, be more conscious of the role of our metabolism and the role prevention takes play.
Yeah, I will say two big things about that. The first thing I want to say is all of these questions have been very good, but they are very elementary. And every audience that I speak to asks these same elementary questions. So I want everybody to realize how shocking that is. Aging is the worst problem for humanity, and it has been the worst problem for humanity for a very long time. So it is really amazing, if you think about it, that we do not all educate ourselves all the time about it. There should be no novices. Everybody should be an expert on aging, and it's not happening. I think that the reason for that is that most people just are terrified of aging and they just want to put it out of their minds and not think about it and get on with their miserably short lives and make the best of it without being preoccupied by this terrible thing that's going to happen. And, you know, maybe that's just cowardly. Maybe we shouldn't do that. We should actually be more focused on it, and then we will solve it more quickly. The other thing I want to say in summary is this isn't really prevention in the way that most people think about prevention. When most people talk about preventative medicine or preventative lifestyles or diets or whatever, they're thinking about what people can do to make metabolism run more cleanly, as I was putting it earlier. And of course, as I said, that is worth doing if you can, but it will only give a very small amount of benefit, even if you do it in exactly the right way for you. And as I mentioned earlier, different people need to do different things. The work that I'm talking about, this damage repair approach, it's kind of the sweet spot between prevention and treatment. And it's prevention in the sense that the best time to apply it is before the person gets sick, but it's also treatment in the sense that it repairs the damage that the body has already done to itself. So, you know, that's really the difference that I think people need to understand.
Okay, thank you very much, Aubrey, for showing us this horizon and for giving us help to have this ambrosia almost ready, right, with senolytics and all these treatments. I really want to appreciate your presentation and discussion. And I would like also to thank all participants for questions. Thank you very much.
My pleasure. Thank you for having me.
Okay, so I would like to thank all our attendees, and I would like to thank Dr. de Grey and Professor Wojda for presentation and for being with us. It was very interesting session. Thank you very much. I know that we will meet in the future because, as you said, staying older and older is not the in the future. It will be not problem. So we'll meet in 2050 or 2080. Thank you very much, Aubrey. You are invited to Poland. Please remember that every time you are in Europe, you can go to Poland. Professor Wojda, thank you very much for your great moderation. And thank you very much. We'll see in the future. Bye-bye.
Thank you. Goodbye.
Thanks.
Bye-bye.
Bye-bye.